Take a minute to make a quick video to show what progress I made today. It took me almost 3 hours, I guess. I made this apparatus here. We've got two fans, power supply. The fans are connected to the Pico. Had to make another Pico, started the headers on there and stuff. Had some troubleshooting with the oscilloscope. Turns out the fans, the logic output is open drain, it's called. And you require a little resistor in there. You see there's resistors to access the data from those fans, because they give you a little pulse once per revolution out of one of the pins. You can see the connector over there. And then there's potentiometers here which control the fan speed. So I can control the fan speed. You can hear it going up. It's going faster. And then it counts the number of pulses, and it tells you... Oh, stop moving. That's not right. Oh no, it didn't. It is moving. It's hard to see. So it says 57 pulses, 56 hertz, approximately. However, it's been varying quite a bit, and it's kind of mysterious. Might need some filtering with a capacitor or something. This is using the state machine of the Raspberry Pi Pico, the PIO peripheral. To count the pulses, which is kind of convenient. There are other ways of doing it, but this is the most accurate and the easiest, and it was it's going to be useful in the future too. So the next step will be to make it so that one of the potentiometers controls the relative speed of one fan versus the other fan. So right now it's only controlling one fan, but it's ready to do the next thing. It's 9:30 though. I think I'm going to call it a day. Probably do the rest tomorrow, and we'll have a system that outputs a PWM signal to control the RPM of the primary fan and the difference between the RPM of the primary fan and the secondary fan. With no PID control loop, it's going to leave that to the controllers of the motor, and this should be able to interface directly to the brushless motor controllers, because they have the same 1 pulse per revolution output and the same PWM input. And then you're going to be able to read the RPM. I'll convert that hertz into RPM and simplify things, clean it up, and you'll have a program that can do approximately what we want it to do. And then we will graph the output of the system in Thonny. I'll change the output of the serial port so that the serial monitor can grab the data and draw us a nice graph. That's not that hard to do. And then we will be able to see, when we assemble the centrifuge and get everything running, how good the regulation is of the motor RPMs, and if it's good enough for our purposes, and we can see if it's fluctuating or oscillating or whatever based on the graph. So that'll be good stuff.